Today we are going to learn about properties of determinants. So there are several properties of determinants which we are going to use to solve so many questions. That is, most of them are prove that questions only here. So first property I have written here, that is the value of the determinant remains unchanged if its rows and columns are interchanged. So I'll just give an example of how it is going to be and what you can infer from that. So maybe you have a determinant like this: A, B, C, D, E, F, G, H, I. Okay, this is the determinant. So you can open it. If you want to find the determinant, you can find it through the first column or the first row, right? So maybe I am referring to the first row of this. Okay, I am referring to the first row of this, and I am going to interchange the elements of the matrix in such a manner that rows take the place of the columns take the place of the rows. So you have already learnt in about the transpose of a matrix. Similarly, we are going to do for the determinant in this case. So it is going to be A, B, C. So the diagonal elements remain in the same place. These are going to exchange. So this is going to be D. G is going to come here. H is going to come here, and F is coming here. Okay. This is how we have changed the rows and the columns. So the property says that the value of this determinant remains the same. That means both of these determinants are equal. Okay. How can I just tell? By a simple statement here is, you can open this one by the first row. Yeah, you're taking the first row and then solving to find out the determinant value. So now here in this case, we'll take the first column. Okay, let us take the first column. In such a case, you are going to get the same value for both the cases. If you want, you can just check it out. So I'm not going to waste time on that. So here I can just simply tell that the first row and the first column is the same, and the remaining columns are also similar, right? D, E, F, G, H, I. D, E, F, G, H, I. Yeah, rows and columns have got interchanged. So if I take this to be the determinant of a matrix, say A, and this will be the determinant of which matrix? Since I have changed the rows and the columns, interchange the rows and the columns, this one is going to be the determinant of A transpose, or I'll write it as AT, A transpose. So what does this property says? That the determinant of A is equal to the determinant of A transpose. This is the remark which you are going to get from this statement. This is the first property. This is generally not so useful, but you should know what is this. Okay, next we'll move on to the second property. Okay, now we have a second property. Second property states that if any two rows or columns of a determinant are interchanged, then the sign of the determinant changes. So if it is positive, it comes to be negative. If it is negative, it goes to be positive after interchanging any two rows or columns. Okay, let me take one example. Say, same example: A, B, C, D, E, F, G, H, I. Okay. So if you feel that many times when you take the second row only, since the second row you have a different rule while opening, because at the starting you have a negative sign, minus for the first term and minus for the third term. While you open through the first or the third one, you have the same rule, right? So but if you interchange the first and the third row, even then the sign changes, right? Not only first and second row, if you interchange, the sign changes. Sign changes even if you exchange these two. Okay, let us expand this. So it is going to be A into EI minus HF, EI minus HF, minus B into DI minus GF plus C into DH minus GE. Okay, this much is over. This is the expanded form. So let me change the first one with the third one. Okay, so what I'm going to get here is, so the second row is going to be the same. This is GHI and this is ABC. Now I'll open through the third row so that I get the similar terms, right? So it starts with A into A into HF minus EI. HF minus EI minus B into GF minus DI. GF minus DI plus C into GE minus DH. GE minus DH. Okay. If I mark this as the determinant delta, right? If I mark this as the determinant delta, you can find out that this is going to have only one negative sign extra with respect to this. Yeah. This has one negative sign extra with respect to this. Therefore, I can write it to be minus delta. Yeah. Since these two have interchanged, I can take out a minus sign outside and get the same terms. That's what I'm telling here. So one extra negative sign that is going to come out here. So that I can infer it to be the determinant of this value is negative of the determinant of this value. That means that if I interchange the first and the third row, the value of the determinant is going to be negative of what is this? Or the sign changes, whatever it means. Okay, that's what it means. That's all about the second one. So if you understand that if you change two rows, so maybe I'm doing two operations together, R1 to R3 and R3 to R2. If I do two of them together, it is going to be minus of minus. So I can directly write it to be plus only. Okay, now we have a third property. The third property states that if any two rows or columns of a determinant are identical. Identical means all the elements are the same over there, then the value of the determinant is 0. So we'll find out how we are going to get that it is equal to 0. So maybe we have A, B, C in the first row and the second row also has A, B, C. Okay, now we have maybe some other elements C, D, E or D, E, F, whatever. I took C, D, E only here. So this I'll mark it as delta. Delta is one of this thing. Yeah. Now I'm going to interchange the first and the second row. First and the second row. So delta becomes, if I interchange the first row, this becomes minus delta. Right? If I interchange any two rows, that is going to be the sign is going to be changed. So I'll exchange these two terms present here. This ABC I'll bring up. This becomes ABC here also. Here it was CD, no change. So what is in R1 will go to R2. ABC was here. So it is going to be ABC. Okay, that much is what we got. So we can find out that delta is equal to minus delta. Right? Just by comparing, you can see as I change the first and the second row, the thing is going to be the same, right? The determinant value is going to be the same since all the entries are same over here. So since I can tell that delta is equal to minus delta, I can bring this to the left side. It becomes delta plus delta is equal to 0, or 2 delta is equal to 0, or delta is equal to 0. That means delta refers to the determinant value of this particular determinant. So what you are going to get here is, if you have any two rows or two columns that are identical, then you can tell that the value of that determinant is going to be 0. That's it about the third property. Moving on to the fourth property. Okay, we have a fourth property. The fourth property states that if each element of a row or a column of a determinant is multiplied by a constant k, k is any scalar over there or any real number other than 0, so then its value gets multiplied by k. So generally we can multiply by 0 also, and all the determinant also becomes 0. So but here what is the thing is, if you have a constant k, you can consider any other real number, that's what. So maybe I have a determinant like this, a, b, c, d, e, f, g, h, I. Okay, I'll expand this. This is a into ei minus hf minus b into di minus gf plus c into dh minus g. Okay, this is all thing. Now I'll multiply the first row. Yeah, first row I'll multiply by k. So it is going to be ka, kb and kc. Now again d, e, f, g, h, I. This is all the thing which you are going to get. So everywhere I'll get ka into ei minus hf minus kb into di minus gf plus Kc into dH minus Ge. Okay, if I mark this as delta, okay, then this becomes K times delta. Okay, this is what the determinant. So what does this tell you? That if you multiply that the first row or the first column or anything, if you multiply one column or one row by a constant K, K can be any constant, so any real number you can multiply over there, then the determinant value of this determinant is going to be K times that thing, or when K is multiplied to that determinant. So you might think, why not in the case of the matrix, when you multiplied K here, if you had 4 elements which did not belong to the same row, in that case you found out that every element should be multiplied by K. So now if I have to multiply one K, L I'll multiply. If I have to multiply this L by this determinant, I need to take it inside any one of the row or one of the column of my own choice. So if I need to take this L inside, I need to write LG, LH and LI. This becomes the value of the determinant. You should not multiply L with everything. That's what you can understand here. One more thing is that if you are given like this and you have some common factors in one row, you can remove that common factors out, right? If you remove the common factors out, you can find out a simpler one, so that this long method is going to be a little bit easier when compared to the big numbers when it comes to be the case of the numbers. Okay, that is one thing. Another thing is, if you have to multiply anything, yeah, you can find out whether these two are going to be proportional. Say A, B, C, D, E, F, K, A, K, B, K, C. Yeah. So many questions will be like that. This determinant, you need to prove that it is equal to 0. So first, for this, we need to remove this K outside. Yeah. We need to remove this K outside. So if you remove common K outside, it comes to be, I can rub this off, and this K comes outside here. Okay, that means that two rows of the particular determinant are going to be equal. In that case, this determinant is going to be 0. That's it, all about the fourth property. Now we'll move to the fifth property. Okay, now we have a fifth property. Fifth property is a little bit long and it is simple to understand, but it is so big. So if some or all the elements of a row or a column of a determinant are expressed as a sum of two or more terms, then the determinant can be expressed as a sum of two or more determinants. Okay, I'll just tell the simple what it means. So if I have A1 plus lambda 1, B1, C1, A2 plus lambda 2, B2, C2, A3 plus lambda 3, B3, C3. Okay, so what is the first part of the sentence means that if some or all the elements of a row or a column of a determinant are expressed as a sum of two or more terms. So if I consider this row now, it has the sum of two terms. Yeah, it is not simple numbers, they are variables. That's why I cannot add both of them, right? So I can just write it in this form, that is A1 plus lambda 1. So what does the second part tell? Then the determinant can be expressed as a sum of two or more determinants. So I have taken only two terms here, therefore only two determinants should be present over here. So I'll take here what is going to be. So the second two rows are going to be the same, C1, C2, C3 plus B1, B2, B3, C1, C2, C3. Okay, what is the entries here is, one of them will be A1 plus A2 plus A3 and the other one will be lambda 1 plus lambda 1, lambda 2 and lambda 3. Okay, in the other way also you can take, maybe you can exchange this A2 and lambda 2, both of them will get the same value. So one from this sum will come here, one from this sum will come here, one from this sum will come here. What is remaining will go to the other one. That's what the logic how we are going to use this property. Okay, next we'll move on to the sixth property. Sixth property, it's the similar one which we have already learnt in elementary operations of matrices. Okay, now we have a sixth property. Sixth property in the textbook you are given a very long statement. Here I have just summarized what does it mean over there. So you are going to have an elementary operation like this. So this was the third elementary operation that we learnt in the matrices lesson. So even if you apply this one, even then the value of the determinant remains the same. So if I have to show the example, I'll write A, B, C, D, E, F, G, H, I. G, H, I. Okay, this much is alright. So I'll apply R1 becomes R1 plus 2 times R2. Okay. So even if I apply this one, it is not going to change. That's why it becomes A plus 2D, B plus 2E, C plus 2F. This is D, E, F, G, H, I. Okay. I can apply this plus or minus. Anything is the same because K is any real number. I can apply that. So in this case we can find out that we can apply any elementary transformation. So the first one was interchanging. While interchanging, the sign was going to change. That was the special thing over there. The second case that we had done in the elementary operations was to add something or something. That was the third one, right? Yeah, that was the third one. The second one was that we can exchange any two rows. Okay, now I'm going to do with example 15. Example 15 says that this is the condition. The condition is the determinant should be equal to 0. Then we need to prove that 1 plus xyz is equal to 0, where x, y, z are different. That means that x is not equal to y is not equal to z, x is not equal to z also. So many terms are present here, it's so irritating. So better use the properties over here rather than just jobless going on doing and opening with the bracket. So we'll start with the answer now. So let me mark this a determinant delta here. So what is this delta is going to be equal to? Delta is going to be equal to, using the property where any column or the row is a sum of two terms, then you can write it as two different determinants. That property I am going to use. It becomes x, y, z, x square, y square, z square, 1, 1, 1 plus x, y, z, x square, y square, z square, x cube, y cube, z cube. Okay, that means that I can just write this as a form of these two things. So equating it to 0, I'll do it the last part. So now I have one more property. Here I am going to apply C1 is going to get interchanged with C2. C2 is going to get interchanged with C3. Okay. So this I want it to go to the right hand side. X, Y, Z I want to commit here. Or I'll do only one at a time. Or shall I do the other way? Okay, first I'll think that this one I need to bring it here. Okay. After that, this x square, y square, z square will come to the first column. This first column I'll interchange with the third column. Therefore, I can write it to be C1 interchange with C2 and C1 again interchange with C3. After. So, two negative sign comes over there. So, this comes to be equal only. Therefore, I can write it to be 1, 1, 1 x, y, z, x square, y square, z square. Okay. That much is over. Next you have x square, x cube. So there is x that is common from there. I'll take out x from the first column. So what you're going to get? First row, it is going to be 1 x square. Okay. Then I'll take y common from the second one. So you're going to take y over there. Then you get 1 y square. I'll take z common out of this. You'll get 1 z square. Okay, these two determinants are going to be equal, right? Therefore, I can write it to be, here 1 is there. So if I take 1, 1, 1 x, y, z, x square, y square, z square as a common factor, then what I'll have with me remaining is 1 plus x into y into z, that is x, y, z. Okay. So if I expand this determinant, what I'm going to get? So rather than expanding, since I have all ones here, I'll do some other operation. So I'll take R1 becomes R1 minus R3, and R2 also becomes R1 minus R3. Okay, since R3 is not going to change, I can subtract from R3 in both the cases. So what it is going to be is, what do we see? So since R3 is not changing, I'll just write that 1 z square. Okay, that much we got. This, both of them will become 0 because 1 minus 1 is 0. Then you have x minus z here, x minus z. Then you have y minus z here, y minus z. Then you have x square minus z square, x square minus z square, and y square minus z square into 1 plus xy z. This much we got. Now I'll bring that up now here. I'll write it here. So 1 plus xyz is common. So however we got that 1 plus xyz term. So we need to prove that that is the only case that is possible. For that we need to open this bracket. So x minus z is common in the first row, because x square minus z square can be written as x plus z into x minus z. So x minus z comes out, x minus z comes out, and what remains inside is 0, 1, x plus z. Okay, then here also 0 is remaining. I'll remove y minus z from here, y minus z. Okay, what is going to remain over here is, here also 1, then you have y plus z here. Okay, then you have 1 z square. Okay, so why I have done the 0 is for my easiness to expand this directly. So I have only one term that is remaining. Further calculation may be difficult. That's why I'll just open this off there itself. So I need to open it from the first column because other two are zeros, only one is remaining. So if I have these three terms, then I have 1 into this is the determinant, what you are going to get here inside. So it is 1 into y plus z minus of x plus z. Okay, that z and z is going to get cancelled. You'll get y minus x. That means that 1 plus xyz into x minus z into y minus z into y minus x. This much we got. So if it is equal to 0, then there are several cases where you are going to get, that means that 4 factors are there, you get 4 cases. So either this is equal to 0, or this is equal to 0, or this is equal to 0, or this is equal to 0. So if x minus z is equal to 0, that means that x is equal to z. Okay. Here if it is y minus z is equal to 0, that means that y is equal to z. If y minus x is equal to 0, then x is equal to y. So in these three cases, we can find that either xy or yz or xz are going to be equal. But what was the question here is that x, y, z are different. Therefore, these three cases cannot be considered. And this is the only case that can be considered since you have the condition that is x, y, z are different. Okay, that's all about the 15th question. We'll move to the next question and then to the exercise. Okay, now we have our example 16. Example 16 is an important one. So you can just see this question is given here like this in this format. But when you see the question, you feel that it's very easy. But it is going to be a little bit different method when compared to the other things which you're going to deal with in the exercise coming. Okay, now we will see the question. So that is 1 plus a 1 1 1 1 plus b 1 1 1 1 plus c. Okay, you need a b c into this term, and this is a simplification of this. We'll just leave this off we want this term now first of all, then we'll just see whether when you multiply this by this bracket you're going to get that thing. Okay, so now we'll take this determinant and mark that at delta. It is going to be 1 plus a 1 1 1 1 plus b 1 1 1 1 plus c. Okay, now first of all I need ABC outside. For that I'll remove a from the first row, b from the second row, and c from the third row. I get a b c. Okay, so this, if I take a from the first row, it becomes 1 plus 1 by a. Here 1 by a, here 1 by a. If I take b from the second row, it is going to be 1 by b, 1 by b plus 1, 1 by b, 1 by c, 1 by c, 1 by c plus 1. Okay, this is the terms we're going to get. So since we need 1 by a, 1 by b terms and all, I'm going to use this. So it is going to be easier than using this terms and getting that. Okay, so now we have something like this. So we have two terms similar over here, or I'll take this somewhere else. So what is the operation I'm going to do here is, I will add all the things because I need the sum 1 plus 1 by a plus 1 by b plus 1 by c. I'll add all the rows, that is I'll write r1 becomes r1 plus r2 plus r3. Okay, I'm doing two steps together, that is I'm going to add all the three. In the first step you can add to the second row and you can add to the third row in another step. So I'm going to do everything together. So it's going to be a b c into 1 plus 1 by a plus 1 by b plus 1 by c is what you get here. Then same you are getting here, 1 plus 1 by a plus 1 by b plus 1 by c. Then one more here also, 1 plus 1 by a plus 1 by b plus 1 by c is what you're going to get. Then what is remaining over here is 1 by b, 1 by c, 1 plus 1 by b, 1 by c, 1 by b, 1 plus 1 by c. Okay, since this is common in one row, I can remove that outside. So it is going to be a b c into 1 plus 1 by a plus 1 by b plus 1 by c into the determinant 1 1 1 1 by b 1 by c, 1 plus 1 by b, here it is 1 by c, 1 by c, then you have 1 by b here and 1 plus 1 by c there. Okay, so we got this term, so we need to show that it is equal to that term, but that means that you have one more determinant. This determinant value is going to be 1 at last, so somehow we need to prove that. So for that maybe I need to subtract something and something here. So for that I'll take the reference 1 as, since we have 1 1 1 here, right? If we have 1 1 1 here, I'll subtract the other two rows, other two columns from this first column. Or what I'm going to do here is, C2 becomes C2 minus C1 and C3 also becomes C3 minus C1. That is what we are going to do now. So I'll rub this off this first part and all. So what it is going to be now, the common terms we just see out first itself, that is ABC into 1 by a plus 1 by b plus 1 by c plus 1. Okay, then you have to do the operation. Okay, so the first column is going to be as it is, 1 by c. Next you have c2 minus c1. So for making these two zeros only we have done this, therefore these two are going to be 0 here. Then you have 1 by b over there, 1 by b, 1 plus 1 by b minus 1 by b, you are going to get 1 here, 1 by c minus 1 by c is 0, 1 plus 1 by c minus 1 by c is 1 here, then you have 1 by b minus 1 by b, that is 0. Okay, now we are going to expand the first row. If I expand this with the first row, what you are going to get is 1 into 1 minus 0, that is going to be 1. So therefore you are going to get that the value of delta is going to be this much only, that is ABC into 1 by a plus 1 by b plus 1 by c. So further if you multiply with this bracket inside, you are going to get ABC plus BC plus AC plus AB. That's what you are going to get. That's all about example 16. Moving on to the exercise. Okay, I'm going to start with exercise 4.2. Exercise 4.2 is an important one. These type of questions generally come for the board exam also. So now we can see that this is, you're asked to prove that it is equal to 0. So how can you prove that it is equal to 0 without expanding and just using the properties is what we are going to see here. So if I have this determinant and one of the column has the sum of two numbers, okay, two things, I have to write it in the sum as a sum of two determinants. So it is going to be xyz, abc, xyz, and one more sum, that is xyz as it is, abc is also as it is. What is remaining here is again abc. So I can find that these two are equal and these two row, or I mean the columns are identical. That means that this determinant is equal to 0 and this determinant is equal to 0. That is what we infer from this. So since this is the sum of these two determinants, I can write that this determinant also is equal to 0. That's all about using the properties. You need to just write what is the property which we have used. So I have considered this one and split it into 2. That is the thing I have done here. That is the only property I have used. So what will be the property I will use here for proving that it is equal to 0? So maybe just by seeing that, I feel that I need to add all the rows or all the columns. So maybe I'll add all the columns. C1 becomes C1 plus C2 plus C3. Okay. If I add all the columns, this determinant becomes A minus B plus B minus C plus C minus A. So all get cancelled, we get 0. Okay. This B minus C, C minus A, C minus A minus B, A minus B and B minus C remain the same. Okay. Then you have B minus C plus C minus A plus A minus B. So everything is going to cancel, we get 0. Then you have C minus A plus A minus B plus B minus C. So it's going to be 0. So since all the elements of a particular row or a column, if this is a column, so since all the elements in this column is going to be 0, the determinant will be equal to 0. That is the property I am going to use here, and also the property of adding all the rows or the elementary operation that we have done here. Okay, moving on to the third question. Okay, now we have a third and the fourth question. These two are very simple, I think. So the third question is all about numbers, but you are not allowed to expand in this. The question is given without expanding, you need to use the properties and then show that it is equal to 0. So if it has to be equal to 0, either two of the columns should be equal, or it should be like all the elements of a particular row or column is going to be 0. So something we need to do for this. So some operation I need to do on column 3. The column 3 I need to change it to column 3 minus 9 times column 2. Okay, what I'm going to get here is, here 2, 3, 5 is as it is, 7, 8, 9 is as it is. So 65 minus 9 times 7 is 63. So 63 minus 65 minus 63, you're going to get 2. Okay, then you have 75. 75 minus 9 times 72. 9 times 8 is 72. So 75 minus 72, you're going to get 3 over there. Then you have 86 minus 9 times 9. 9 times 9 is 81. So 86 minus 81 is 5. Right? So you can find out that these two columns are equal. That is C1 is equal to C2. Therefore, the particular determinant is going to be 0. Okay, next we'll move on to the fourth question. So maybe it cannot be, mostly it is going to be similar to like this. So where one of the columns is going to be equal to the other one. Okay, this is C3, right? Okay, now see here you can see that 1, 1, 1. We just leave it off. So you have AB, B, AC and one BC here. Okay, here AB, BC, AC. AB is here, BC, AC is here. So I can somehow get a common factor out of this by, first of all, I need to use elementary operation where I'll take the third column C3 to C3 plus C2. Okay, this becomes 1, 1, 1, BC, AC, AB. Then you have AB plus BC plus AC. Then AB plus BC plus AC and AB plus BC plus AC is equal to 0. Okay, I need to prove that it is equal to 0. So this is the determinant. So we'll get again 1, 1, 1. then BC, AC, AB, then 1, 1, 1. If I take common outside, that is AB plus BC plus AC is taken common outside, we can find out that the first and the third column is going to be equal, that is 1, 1, 1 and all. So since they are going to be equal, you can conclude that similar to this, it is equal to, the determinant is going to be equal to the 0. Okay, next we move on to the fifth question. Fifth question is very similar to the property where we'll deal with the sums and all. But most of the things here is all about elementary operations. You need to be very clear with how to use elementary operations and where and what to use. Okay, now we have our fifth question. Here we are going to use just the elementary operations and nothing else in this question. Okay, now the first thing is we can make out that only column wise operations can be worked out here. Sorry, the row wise operations can be worked out because column wise they do not have any relation. Here you have ABC terms, here you have PQR terms, here XYZ terms, where you get ABC here, PQR here, XYZ here. So you are not going to relate with any column wise operation, you are going to do only the row wise operation. Okay, first of all, maybe I'll take the first row. First row I'll add with all the other rows. So I'll get R1 plus R2 plus R3. So this comes to be 2 times A plus B plus C. This is also 2 times P plus Q plus R and 2 times X plus Y plus Z. Okay. Then you have here C plus A plus B, R plus P, P plus Q, Z plus X, X plus Y. Okay, this is all what we got here. So what is the next step we are going to do is remove this 2 outside and okay, I'll remove the 2 outside now itself. Then I'm going to use the operation where R2 becomes R2 minus R1 and R3 becomes R3 minus R1. Okay, that's much I'm going to do. First of all, I'll remove this 2 outside. This comes to be A plus B plus C. This is P plus Q plus R. This is X plus Y plus Z. Okay. So if I need to do the operations. So I have already taken 2 outside that I have not written as another step over here. So you are going to get A, B, C. These 2 I'll write it here as well. Yeah, A plus B plus C you have. Then R2 minus R1. That is C plus A minus A plus B plus C. So what I'm going to get here is minus B. Similarly, you are going to get here minus Q. And here you are going to get minus Y. Okay. Next you have A plus B. That is R3 minus R1. A plus B minus of A plus B plus C. So A and B get cancelled. You get minus C. So similarly we are going to get minus R and minus Z. This is all about this. So since all of them have the common factor minus 1, I can remove 1 minus here from the second row. Then from the third row, 1 more minus I can remove. So minus of minus. So 2 minuses I got. So I'll cancel off all this and make this plus. Okay. So the next step, what I'm going to do here is, it is going to be, I need to convert this into APX, not A plus B plus C, P plus Q plus R and all. So for that I need to write R1 becomes R1 minus R2 minus R3. Okay, that's it what we're going to do. That is the last step. So it is going to be here B, C, Q, R and Y, Z as it is. Then we have A plus B plus C. A plus B plus C minus B minus C is going to get A. Similarly get P and here X. This is what the right hand side we are asked to get. Next you have your sixth question. In the sixth question is a very simple one. I'm just going to tell it vocally over here. Here it is given the determinant of a skew-symmetric matrix. So an example of a skew-symmetric matrix is given in the question. So you need to just prove using properties. So what is a property for a skew-symmetric matrix is that, so when you find a determinant, it has to be equal to 0. That is what we have seen in the previous exercise and all. So here we can find out that when we prove that using the properties, we always need to multiply with a minus sign. So if delta, not delta, determinant of A is equal to minus of determinant of A, then determinant of A is equal to 0. This is the thing which we are going to use in the 6th question. You are just going to prove that determinant of A is equal to minus of determinant of A. So for that, you need to use one more special thing. So now let me write the question over there. I'll just tell it properly. You have 0, 0, 0, since it is of a skew symmetric matrix. Then you have minus A, B, C, A, minus B and minus C. This is the skew symmetric matrix. So this is the determinant of A. So what is the minus of determinant of A? So minus is same as if I multiply minus by each row. So it is coming to be 0, minus A, B, and this is going to be A, 0, C, minus B, minus C, 0. Okay, I have took one minus sign inside out of this 3. So these two just make it to a plus only. So each row I have taken one minus sign. So 3 minus signs I have taken inside, which we are going to get it is equal to like this. Okay. At last we can get that this minus of this determinant of A is same as this thing. These two are going to be equal in this case. Therefore the determinant value of this skew symmetric matrix is going to be 0. That's all about the 6th question. We'll move on to the 7th question now. There are a series of questions that are very similar, so I'm going to do a bit faster now. Okay, now we have a 7th question. 7th question is all about a determinant that is present here. So this determinant, you are asked to prove that it is equal to this, that is 4a square, b square, c square. So it is a product of so many terms. So first of all, we can assume that we can take out some terms first of all. So here you can see that a is common in the first row, b is common in the second row, and c is common in the third row. So I'm going to take a, b, c outside. This is LHS, right? I'm taking a, b, c outside. This comes to be minus a, b, c. This is b, this is minus b, this is c, and this is a, b, and minus c. Okay, this is so similar you are going to get. So the remaining part is doing something with this 4 and with something with a, b, c. One more a, b, c we are needing. So we'll do like r1 to r1 plus. So this was a, right? This was a. I'll convert r1 to r1 plus r2 and r3 also to r3 plus r2. That means that second row I'm going to add. So anything I can do. So if I add this to this second row is as it is not going to change. So a plus a becomes 2a, b minus b is 0, then you have minus c plus c, that is going to be 0 here also. Then you have c plus c is 2c here, then you have b minus b is 0, then you have minus a plus a, that is going to be equal to 0. So these many things we got. We have also one abc here. So from this row I can take out 2a common, from this row I can take out 2c common. So what we are going to get here is 2 is here, from here we'll get 1 2, from here we'll get one more 2. In total we are going to get 4, and ca is there, so you are going to get a square c square b. So we are in need of one more b only now. So we have 0 0 1 a minus b c 1 0 0. So maybe I'll expand with this one. If I expand with this one, I'm going to get b over there. So that is 4a square b square c square is what you are going to get at last in this question. So we need to just take care about what we are going to get here. So the next question is all about getting the factors. Factors can be got out through elementary operations only. Okay, now we have our 8th question, first subdivision. Here you have this determinant and you are asked to find these 3 factors for this determinant. Okay, so we need to use the properties over here. easy properties. We have already done such a question. So for that, what we do is, we'll since we have 1 1 1 here, we need to convert any two of them to zeros. So let me convert the second and the third one to zeros. So let it be R2 minus R1, and R3 also becomes R3 minus R1. These two operations I need to do here. That time I'll get so the first one is not disturbed, so it remains as it is, so whatever it is. Then these two become 0. For that case only we have done this. And also we have b minus a here, so this becomes b minus a, and this is c minus a. This is c square minus a square, and this is b square minus a square. So now we know that what we need to do is expand using this. But first of all, let us take the maximum factors outside before expanding. Otherwise this becomes a very big and all. So it is going to irritate us a lot while simplification and all. So the thing is, we need to take b minus a factor, c minus a factor outside, so that we get something like that. So what do we get here? So b minus a I have taken outside from the second one, and c minus a I have taken from the third one. This is 1a square, and then you have 0 0 1 1 b plus a and c plus a. Okay, this is all about this. Now we need to just expand this determinant, leave these factors. This determinant is 1 into c plus a minus b minus a. Okay, this 2 I'll get cancelled. So you get one more factor that comes to be c minus b. Okay, so you have b minus a into c minus a into c minus b. Okay, this was b minus c, right? So you have b minus a, c minus a, c minus b. So maybe one minus sign I'll take outside from this, and from this also I'll take one minus sign outside. So this becomes a minus b, and this was the second term, that is b minus c, and the other one was c minus a. This is the right hand side. Okay, the second part of this is also very similar to this. I'm going to read it very fast now. Now we have a second subdivision here. Here you have 4 factors you need to get from this, but this is very simple. From where we'll get this 4 factors over here? So first of all, maybe 2 of these factors can be easily found out from this by subtracting one of this. So maybe I'll take the second column. Second column is c2 minus c1, and also the third column to be c3 minus c1. So this becomes 1a cube. This is as it is. This 2 becomes 0. Okay, then you have b minus a, this is c minus a, this is b cube minus a cube, and this is c cube minus a cube. Okay, this is what we get. So from this, maybe I can remove b minus a common from this. What is the thing that is remaining over here? For that we need the formula or the identity we learned, that is a cube minus b cube identity. You can tell that a cube minus b cube is equal to a minus b into a square plus ab plus b square. Okay, this is all about this. This is a thing. So a minus b, or this b minus a in this case, is going to be the factor of this. So what is the thing that is remaining over here is a square plus bab plus b square. So we'll see what is going to be. So 1 0 0 a cube 1 1, then you have b square plus ab plus a square. Okay, then in the third column you have c square plus ac plus a square. Okay, then you have 2 factors, that is b minus a, and then you have c minus a, that is multiplied to this determinant. Okay, that's it what we have. Then we'll see what is remaining with us. So now we'll expand this. If we expand this, what is the thing we are going to get? So b minus a and c minus a is already there. Okay, then you have 1 into c square plus ac plus a square minus b square minus ab minus a square. Okay, a square and this a square will get cancelled. Okay, Then you have c square minus b square, ac minus ab. So what is the common thing that we need to take out from that? Okay, we have b minus a, c minus a here. Then you have c square minus b square. So maybe c square minus b square, I'll write it to be c plus b into c minus b. Okay, c minus b into c plus b. These two things I'm taking together. Those two I have taken now. The thing is remaining here, ac and minus ab. Then you have 1a plus a into c minus b. Okay, from this we can find out that c minus b is going to be common. So we'll remove that c minus b common. So this becomes c minus b into c plus b plus a, or a plus b plus c. So this I'll make it a minus b, and this I'll make it b minus c by taking one negative sign outside from each of these brackets. So if I take two negative signs, it becomes positive. So at last you get a minus b into b minus c into c minus a into a plus b plus c. That is the thing here. A plus b plus c is the given determinant. That is what we need to prove in this question. That's all about 8th question. We'll move on to the 9th question. Now we have the 9th question here. 9th question is like this. So we need to find these 4 terms. So first of all, maybe the first 3 terms are very easier to find out than the 4th term. So for the first 3 terms, I'm going to use this thing, that is R1. I'm converting it into R1 minus R3 and R2 to R2 minus R3. Okay, for this I need to substitute what I'm going to get. This is going to be x minus z, y minus z, then z here is z square and xy, they remain as it is. Okay, then we have x square minus z square, then you have y square minus z square, yz minus yx, then you have zx minus xy. Okay, that is equal to how much? So now we need to take these terms outside. If we need to take these terms outside, we need to take the factors, common factors here. So x minus z is one of the terms. So we'll take x minus z from here, from the first one. Second one will take y minus z. Okay, we are taking y minus z. This becomes 1 1. This is z and z square and xy as it is. Okay, that much is as it is. Then you have x square minus z square. That what remains here is x plus z. Then you have y square minus z square. What remains is y plus z here. Okay, then you have yz minus yx. So y is common over there. If you take y common, you get z minus x. But I have taken x minus z outside. Therefore, minus y remains here. Similarly, minus x remains here. Okay, that's all the thing what we are going to get over there. Now we'll move on to the next part. What should we do in the next part is to just get the other 2 terms. 2 terms are already with us. So we need to get the other 2 terms with the help of some other thing. So what should we do over there? Okay, for getting the one more term, maybe I can subtract this from this so that I get 1 0 also. For that, I'll consider R1 becomes R1 minus R2. So what does this change it to? So you have x minus z here and y minus z is also with you. Then one more term somehow we need to get, right? For that, we'll do 0. Yeah, this was 1 y plus z minus x z square xy is common outside there. Now we have x plus z minus of y plus z. Z and z get cancelled. Only x minus y remains over there. X minus y remains. Then you have minus y, then minus of minus x. That you get again x minus y. So therefore you get x minus y common. If you take it outside, you get x minus z into y minus z into x minus y. Okay, then you have 0 1 1 1 y plus z minus x xy z square and z. This is all we get. So the remaining part might be just to do whatever we want just to expand it, because we have got all the three factors. One more factor is remaining. The last factor always we get only after expanding. So now we'll expand. We leave out this 3. I'll just expand this and show that it is equal to this thing. So for expanding, I can start with the one of these. So maybe I'll start with this column. So I should start with -1 because that is the second one. So -1 into xy minus z square. Xy minus z square. Okay. Then plus z into then you have minus x plus y minus x minus y minus z. Minus x minus y minus z. This is all we get. So somehow we need to get those terms over there. So something is going to get cancelled. We know that much. So we have xy minus xy here. Okay. Then you have plus z square. Okay. Then you have plus minus xz minus yz plus minus z square. Okay. Plus z square and minus z square get cancelled. You have minus of xy plus xz plus yz. Okay. So this term which we got. So why did this minus come here? Okay, we'll just check once more. We need to get the terms in this proper order. So it was x minus y we have, y minus z we have, z minus x. We have x minus z. If you multiply this -1 to this x minus z, we are going to get that value. Okay, so it is going to be this factors into this minus of xy plus xz plus yz. That is going to be the product, that is RHS. That's all about the 9th question. Okay, now we have our 10th question. Here first and second part are similar, that's why I'm going to do the first one. Second one is simpler than that. So now we have a first part. X plus 4 and 2x are only the terms that are present here. So what is in the RHS, we need to somehow prove that. So for that, the easiest way I know that R1 I'll add up all the rows. Okay, for that it becomes 5x plus 4 everywhere in the first row. 5x plus 4, 5x plus 4. Okay, so LHS. Okay, then you have the same things, that is 2x, x plus 4, 2x, x plus 4. Okay, this much we got. Now we are going to remove 5x plus 4 outside. If I remove 5x plus 4 outside, what we are going to get is 1, 1, 1, 2x, x plus 4, 2x, x plus 4. Okay, now the remaining thing is just getting 2 zeros and expanding. If you get 2 zeros somehow, for that we need to consider the columns now. Yeah, columns. So C2 becomes C2 minus C1 and C3 becomes C3 minus C1, such that here you'll get 2 zeros because here everywhere is 1. If I subtract this, I get 2 zeros over there. So 5x plus 4 is already present. 5x plus 4. Then you have 1, 2x here. Okay, the remaining part is here 2 zeros you wanted, so it had to be 0, 0 only. Then you have x plus 4 and 2x. That is x plus 4 minus 2x comes to be 4 minus x. Okay, 2x minus 2x is 0. 2x minus 2x is 0. X plus 4 minus 2x again comes to be 4 minus x. Okay, this is so direct. Expand using the first row. If you expand using the first row, we are going to get, so 5x plus 4 is already there. After expanding with the first row, 1 is there. So 1 into the determinant of this, that is 4 minus x whole square. 4 minus x whole square. That is RHS. So similar here also you will get the same thing. So maybe if you want, I'll do, if I add all the rows, I'm going to get 3y plus k, 3y plus k, 3y plus k. Okay, 3y plus k. Then y plus k, y plus k. See, it's so similar. Here 2x, in place of 2x I have put y, and in place of x plus 4 they have put y plus k. Okay, So it is going to be very similar over there. So if you remove 3y plus k outside, you'll get 1 over there. Then we are going to use the same thing, that is c2 minus c1. If we use c2 minus c1, sorry, we are going to get 1 0 0, then y is here itself, then k, then 0 0 k. Okay, again for finding the determinant, we'll get this is equal to k square. So k square into 3y plus k is going to be the answer for this. That's all about the 10th question. We move on to the 11th. Okay, now we have 11th question, first part. This is an important question because you have 3 terms of a plus b plus c. So it becomes very difficult to take it out. So we need to just know the method properly over here. So it's very similar method, but still many times it becomes a difficult task also. So first step is same everywhere. So R1 becomes R1 plus R2 plus R3. Adding all this up, so you are going to get somehow a plus b plus c over there. A plus b plus c here, a plus b plus c here, and a plus b plus c here. If you want, you can just try and see how you are going to get that. Okay. This is b minus c minus a, this is 2b, this is 2c, and this is c minus a minus b. So now we got a plus b plus c in the first row, so we can take that out. So we are going to get a plus b plus c into 1 1 1 2b 2c, b minus c minus a, 2b 2c, c minus a minus b. Okay. Now the step is to just make 2 zeros. For that, making 2 zeros, I need to use the same method. C2 becomes C2 minus C1 and C3 becomes C3 minus C1. So the first column remains the same. First column remains the same, that is 1, 2b, 2c. Then you have 0, 0. Then you have C2 minus C1. B minus A, B minus C minus A minus 2b. So it becomes minus of a plus b plus c, or minus a minus b minus c. Then 2b minus 2c 0. This is also 0. Then similarly here also you are going to get minus of a plus b plus c. Okay. If this much is done, your answer is almost over. So if you have got a plus b plus c here and here also. So in both the cases I am going to take out minus of a plus b plus c outside. So both the places if I take minus, it's going to be plus, however. Therefore you are going to get a plus b plus c whole cube. A plus b plus c whole cube. Then 1 0 0. Here 2b and 2c is there. Then 1 0 0 1. Okay, if you expand this, you are going to get 1. Therefore this is going to be the answer for that. So similar question is the second part also. Okay, 11th question, second part. It is very very similar to the first part only. Here also, but here you are going to do it with a column, because when you get here only we are going to get 2 times x plus y plus z. So 2 times x plus y plus z. Here 3 places you will get. Okay. After that, what is remaining is as it is, y plus z plus 2x, y x plus z plus 2y. Okay. Now from here we are going to take 2 into x plus y plus z common outside. Again you will get 1 1 1 here. We are going to use the same method that we used in the previous one. So similarly we are going to get that answer. I am not going to do that now. We'll go to the 12th question. Okay, now we have our 12th question. 12th question is one of the similar one only, but still I am going to do this. This is a little bit different. So you have 1 and x here instead of something else. Only x is present as a variable. So in the right hand side you have 1 minus x cube whole square. That means that you need to get 2 terms only. But when you see 1 minus x square, we can remember one more identity. That is a cube minus b cube is equal to a minus b into a square plus ab plus b square. Okay, so 1 minus x cube is going to be equal to 1 minus x into 1 plus x square. Okay, that is what we infer from the given identity that we have already learned previously. So we need to get those 4 terms. So I mean these 2 terms 2 times. That means you need to get the 4 terms over there. So for that, easiest thing, add all the rows. R1, R1 plus R2 plus R3 I'm going to add. For that I'm going to get 1 plus x square. So here also 1 plus x square. Same thing here. Okay. So after this we are just going to write whatever it is given here. 1 x square x1. Okay. So 1 plus x square I have taken outside. So it is going to be, the determinant is going to be 1 1 1 x square x 1 x square x 1. Okay. Now the remaining part is getting two zeros. For getting two zeros, what I need to do is, maybe I'll take the column operations, C2 to C2 minus C1 and C3 to C3 minus C1. Okay. These two operations I need to do in order to get two zeros over there, so that I can expand it directly over itself. Okay. Now we have 1 plus x square here. Then you have 1 x square and x here itself. This 2 I wanted it to be 0. It became 0 here also. This is 1 minus x square. This is x minus x square. This is x square minus x. And this is 1 minus x. Okay, somehow some common factor I need to take it out, otherwise it's going to be very irritating. So 1 minus x is a simpler one, rather than getting out somewhere 1 plus x square as one more thing. So 1 minus x is common out of this. We can just see that 1 minus x is common out of this. Here it is x square minus x. So it is x into x minus 1. Or I can take 1 minus x from that by putting one more negative sign. Then you have x square minus x square. So it is x into x minus 1, right? And you have 1 minus x here also. So those things I need to take it out. So what we are going to get is here 1 plus x square I have got, and this is the determinant, x square and x, then 0 0. From here I have taken 1 minus x. I have taken 1 minus x from here. Here you get 1 plus x is remaining. Then x square minus x is present. So minus x is remaining. X minus x square is there. So only x is remaining. So from here also I have taken one more 1 minus x. So only one x is remaining. Then here one minus 1 is remaining. Now the thing is just to expand. So I'm not going to write the factors again. So I'm just going to expand this determinant. So this determinant becomes 1 into minus 1 minus x plus, see, minus 1 minus x, minus of minus is going to be, here it has to be plus only. Okay, so one negative sign is extra over here from somewhere. So there is a mistake, I think. So since it is 1 minus x I have taken outside, this has to be plus only, right? So this is 1 plus 1 plus 1. 1 plus x square. Yeah, 1 plus x square is what we got now. That's it. You got the 4 terms. By seeing these 4 terms, you can just tell that it is going to be the product of 1 minus x square and 1 minus x cube and 1 minus x cube. That's all about the 12th question. Moving on to the 13th one. Okay, we have a 13th question here. 13th question is also an important question because it is a little bit different when compared to the other ones. So you have here 1 plus a square plus b square whole cube. So you need 3 factors that are same, that is 1 plus a square plus b square. So but we have one 2ab term over there. 2ab term over there. For that we need to get rid of that by using some elementary operation. So we need to use something. So based on the third one, because only the first and the second row have the 2ab terms. So that AB has to be get rid of. So we'll take R1 to R1 plus B. B is some constant, right? So we're considering B into R3 and R2 to R2 minus A times R3. Okay, this operation I'm going to do now. So now we have got this operation, we need to do something. So R3 is not going to change, that's why I'm going to write it as it is. So it is 2b minus 2a, then 1 minus a square minus b square. This must be got. Now we have to make it somehow 0. So these two 2ab terms make it to be 0. Then you have 1 plus a square minus b square plus b into 2b. b into 2b is 2b square, so I need to add 2b square here. This becomes 1 plus a square plus b square. Okay, then you have this 2b here, so we'll take minus 2b. Minus 2b, then b times this, that is plus b minus ba square minus b cube. Okay, we'll take b common outside, so it is minus 2 plus 1 minus a square minus b square, or I can write it to be minus b into 1 plus a square plus b square. Okay, so I'll write that minus 1 into 1 plus a square plus b square. Somehow I need to get in this format, that is 1 plus a square plus b square. So this somehow we need to do. So it is 1 plus 1 minus a square plus b square. Okay, so minus 2a into minus a, that is going to be plus 2a square. So this is going to be 1 plus a square plus b square. Okay, what about the third position? So it is 2a minus a into, that becomes minus a plus a cube plus ab square. I'll take a common outside, that comes to be 1 plus a square plus b square. So it is a into 1 plus a square plus b square, that is common outside of it. So now I need that 1 plus a square plus b square terms, so I need to take it out from the first and the second. So if I take two of them, this becomes 1 plus a square plus b square whole square into 1 0 0 minus b 1 a 2b minus 2a 1 minus a square minus b square. This much we got. So we need to get somehow, we have got 2, most of our work is done. So only one more somehow we need to get by expanding or something only. Yeah, nothing else. So what do we need to do? Maybe we'll expand using some other, or we'll take the first column. Using the first column, so 1 plus a square plus b square whole square is already there. Okay, now we have 1 into 1 minus a square minus b square minus of minus 2a square, that becomes plus 2a square. Okay, that much is over. Then you have plus 2b, because this one is 0, negative sign, no problem. So here you have 2b, so that 2b, this becomes minus b. Minus of minus b comes to be plus b. Okay, that's all about that. So what does this term come to be? Okay, that is 1 minus a square minus b square plus 2a square. So minus a square plus 2a square comes to be a square. So 1 is over, a square is over. Okay, then you have minus b square plus 2b square, that comes to be plus b square. That is the third term. Yeah, 2 terms we have already got. One more, 1 plus a square plus b square we got just by expanding. That's all about the 13th question. We'll move on to the 14th, that is the last before the MCQ. Okay, now we have a 14th question. 14th question, this is a strange type of question. So you have 1 plus a square plus b square plus c square. It's a strange one, right? Because there is no product. Only one term is given. Somehow we need to get that term. There is no other option. So if we had more than one factors, somehow some other factors will mix up and get it at last. So but here you have only one. So we need a square, b square and c square term. But from where this AB, AC, BC and all those have come? So the commonest methods that are used here is removing ABC and again putting ABC. So that is the meaning. So we'll remove ABC outside. I'll tell from where I have removed A, from where I have removed B and from where I have removed C. So if I remove A from the first column now, I removed A from the first column. That comes to be A plus 1 by A. This becomes B and C. Okay. I have removed B from the second column. That comes to be A, B plus 1 by B and C. Okay. Then you have, I have removed C from the third column. This becomes A, B, C plus 1 by c. Okay. Now again I'm going to insert this a, b, c inside the determinant. But I'm not going to insert in the form of columns. Now I'm going to insert in column rows. So I'm going to multiply a with the first column. That becomes a square plus 1, a square and a square. Okay. Then you have b with the second row. So it is b square plus 1, b square. Okay. Then you have c with the third row, that comes to be c square and c square plus 1. Okay, this much we got. So this is very easy to get now, right? Add all the terms. So r1 becomes r1 plus r2 plus r3. So it is going to be 1 plus a square plus b square plus c square, b square, c square. Then here also 1 plus a square plus b square plus c square. This is 1 plus b square, c square. Here also 1 plus a square plus b square plus c square. Then we have b square and 1 plus c square. This much we got. So we got this term 1 plus a square plus b square. I'll bring it here. This is going to be equal to 1 plus a square plus b square plus c square. And what is the determinant that is remaining? Somehow we need to prove that it is equal to 1. So it is 1, 1, 1. B square, c square, b square plus 1, c square, b square, c square plus 1. Okay. The remaining thing is c2 to c2 minus c1, c3 to c3 minus c1. Okay. So I'm going to do only with the determinant, that 1 plus a square plus b square plus c square. Already we have got. Somehow we need to prove that it is equal to 1. So it is going to be 1 b square c square 0, 0. Okay, this 1 plus b square minus b square is 1. This is 0, this is 0, this is 1. Yeah, expanding using the first row, we are going to get 1 into 1 minus 0. That is same as 1. Therefore, this determinant, I'm expanding using the first row. So I'm going to get 1 into 1, 0, 0, 1. Yeah, we are going to get 1 as the answer. That's all about the 14th question. All the questions are over. Prove that questions. Now we need to move on to the MCQ questions. Let us read the first question of MCQ. Here there is a question given. You need to find the determinant of KA. Determinant of KA. So what is KA? K referring to the whatever it is, that is the scalar, multiple or any real number in other words. So it is given that A is of order 3. A is of order 3 by 3 is a square matrix. So you can find for only for a square matrix, right? So square matrix it is. So you are asked what is the value of the determinant of K into A. So you can find out that there are 3 rows, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. By the properties we know that we can get 1k from one row. So here you have k, 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 k. Yeah. If you remove 1k outside, that means that all the k from one row has come out. So if you take 1k outside, from here one more k comes from one row, second row. From the third row, one more k comes. That comes to be k cube. K cube into that particular determinant, wherever it is. Right? Therefore, it is k cube into determinant of A. Not simply k into determinant of A. Therefore, it is going to be the option C. Okay. Next, we'll go to the 16th question. 16th question is just about reading. So, which of the following is correct? A. Determinant is a square matrix. Determinant is a number, not a square matrix. Therefore, it is wrong. Determinant is a number associated to a matrix. No, it cannot be every matrix. It can be maybe some rectangular matrix where it is not square. Such things do not have a determinant. Therefore, B is also wrong. C. Determinant is a number associated to a square matrix. That is correct. That's all about the definition of the determinant. Okay. That's it all about the properties of determinants. In the next part, you are going to learn about the area of a triangle